Hi, welcome to another video. So this is the second video in a lead up to the vacuum and pressure sensor video I'm going to show. And I promise you, David Andrews, the next video is going to be the pressure vacuum sensor. So it's for beginners. So what does this AND, when you see this AND in code, like this example here, result equals packet AND, this is a hexadecimal number, so result equals packet AND 0x38. Or it could be the count equals AND 0x38, or the value from an ADC. Result equals value AND 0x38. This AND means you want to select exclusive bits from a byte. And in case you don't know, AND is an ampersand, also known as AND. So why would you want to select exclusive bits? So certainly in a packet of data coming on the internet, you might want to single out 3 digits, make sure it's a right address or something like that. And in the case of this vacuum pressure sensor from Honeywell, 2 bits of data are status bits, nothing to do with the value of the vacuum or pressure you're measuring. So you want to eliminate the status bits and just concentrate on the data. So that's why we would pick out exclusive bits. So first of all, you've got to understand a byte. A byte is 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. And in computing and programming microcontrollers, those bits of a byte represent a decimal number. So 8 bits, bit 1, bit 2, bit 3, bit 4, bit 5, bit 6, bit 7, bit 8. Bit 1 equals a 1, bit 2 equals a 2, 4, 8, 16, 32, 64 and 128. 2's complement, so 2 times 1 equals 2, which is the same as writing 2 to the power of 1 equals 2. This symbol here means to the power of. It's actually known as a correct. Now we know this is 2's complement, so 2 times 1 equals 2, or 2 to the power of 1 equals 2. See here, 2 times 2 equals 4, or 2 to the power of 2 equals 4. 2 times 2 times 2 equals 8, 2 to the power of 3 equals 8, because we've got 3 2's there. 2 times 2 times 2 times 2 equals 16, or 2 to the power of 4 equals 16, because we've got 4 2's there. And here we have 5 2's, 2 times 2 times 2 times 2 times 2 equals 32, or 2 to the power of 5 equals 32. You can try it on your Windows calculator. Put in the number 2 on the scientific calculator, then hit the button on the left hand side, looks like this, X over Y, and then hit whatever number you want. 1, 2, 3, 4, 5, up to 20, 30, 40, and you'll get 2 to the power of, and then your number. Hit equals and you'll get the result. So although I said this is bit 1, bit 2, 3, 4, so on and so forth, in computing and certainly microcontrollers, we've just wasted a position here. We've started with 1 and we've missed position 0. So in computing and programming, you start with 0 because 0 is a number. Now we've got rid of the normal counting, because that's how many fingers we've got. We start with 1, 2, 3, 4. In computing, start with 0. We've still got 8 positions, or 8 places. 7, 6, 5, 4, 3, 2, 1, 0. That's 8 numbers. And we've still got the same decimal values assigned to those positions. And the same is true of a string. If you're working with strings instead of numbers and values, this YouTube, for example, in a string, so it's 7 bits long and I'm printing out. This isn't me just typing this on the screen, it's my function showing the value of this string position 3. So 0, 1, 2, 3. We have a capital T for YouTube. Capital T in binary, we've got no 1s, no 2s, we've got a 4, no 8s, we've got a 16, no 32s, we've got a 64, and no 128s. That's an ASCII value of 84 equals capital T, 64 plus 16 plus 4. That is what my keyboard sent to the computer when I typed in YouTube this morning. Here's a quick look at the ASCII chart. So finally, which was the original topic of this video, a whole byte of 1s equals 255. If you add all these numbers up, 128 plus 64 plus 32 equals 255. Let's say we want just these parts of that packet. So hexadecimal 38, I've shown on Windows Calculator you can convert decimal or binary to hexadecimal. So to make it easier to understand in this example, hexadecimal in binary are these 3 ones here. Just selecting these bits here, bit 3, bit 4, bit 5 in the byte. So bit 3, bit 4, bit 5 equals 56. So bit 3, 0, 1, 2, 3, we've got an 8, a 16 and a 32. Add those 3 bits up, you'll get 56. So although the Honeywell pressure sensor has a 16-bit register, so if it's got a 16-bit register, this is an 8-bit, and counting left, you just keep on multiplying these by 2. So we've got 128 here. The next position in the register to the left would be 256, then 512, 1024, and it keeps on multiplying by 2. But just in an 8-bit packet, these are the values. And the Honeywell pressure vacuum sensor I'm using, the first 2 bits in the upper byte are status bits, and you've got to exclude them from your value. So just before I go, here's a look at Windows Calculator. There's a standard view, scientific. I made a mistake earlier. I said x over y. It's y over x. So we want to look at 2 to the power of something. So click on the 2 to the power of, let's say 8, 256, and you see the little caret symbol up here. And the equation 2 to the power of 8. 16-bit register, so 2 to the power of 16 equals 65,536. Although in a PIC microcontroller it would count up to 65,535 because it uses position 0 as a starting point, not 1. Down to programmer. Start at binary 7, 6, 5, 4, 3, 2, 1, 0. There's our 8 bits. Decimal value 255, hexadecimal FF. And from our example on the screen earlier, we were looking at the middle ones here. So if I type 0, 0, 0, nothing happens because they're not significant, they're not justified by anything. So I want bit 7, 6, 5, 4, 3, and then justify them by putting in trailing zeros. 2, 1, 0. Now the calculators put those leading zeros in, but we want 5, 4 and 3. So values 513, decimal 56, hexadecimal 38. And a quick look at the data sheet, which is why we need any of this. So that Honeywell pressure sensor, we read 2 bytes to read the pressure, 4 bytes if we want the temperature. And you'll see here the most significant bits in that first byte are status bits, status bit 1 and status bit 0. So if you include those in your value, you'll mess up your pressure. So you've got to exclude them. And then down to the bottom here, reading the temperature, you've got to exclude the last 5 bits. Hopefully this has given you an insight into picking individual bits from a byte. If you've got any questions, just leave a comment. Thanks for watching.